In this lecture, we will discuss non-parametric density estimation techniques. In our previous lectures, we have seen the parametric density estimation techniques such as maximum likelihood estimate. However, when we work with real data, the data might not fit in any parametric form. Methods that does not require an assumption regarding underlying density functions are useful in many real applications. In this section, we discuss such non-parametric density estimation methods, namely the Parsen window and k-nearest neighbor. The non-parametric density estimation procedures rely on the fact that probability p for a vector x to be in a region R is given by the integral where we integrate the underlying density over the region. However, we do not know the underlying density in most of the cases. So, suppose that n samples are drawn independently and identically distributed from the underlying density function p of x, such as x1 to xn. The probability that k of these n samples fall in the region R is given by the binomial law, which is here. And the expected value for k is, which is the number of samples that fall in the region R, is given by n times p. Suppose that we have a set of feature vectors x, d-dimensional feature vectors, where we define regions from R1, R2 to R infinity maybe. When we assume px to be continuous and r very small, we can also assume that this integral is equal to probability density of x times v, which is the volume of the region. And when we combine equations 1, 3 and 4, which are these equations, since expected value of k is np, we can write that k is almost equal to n p x times v, since equation 4 is that. Maybe I should write here p is equal to, yeah. So probability of x becomes, that is the underlying distribution, becomes almost equal to k over n over v. So what was k? K was the number of samples in the region R, n was the number of all samples, and v is the volume that we are considering. So, given a hypercube Rn, which is our region, and one edge of the hypercube is Hn, the volume of the hypercube can be calculated by this equation, which is the Hn over d. In order to make density estimations by specifying a sequence of regions, we can use two distinct methods. Either we specify a volume Vn as a function of n such that Vn equals 1 over n, and shrink the volume as n increases, which is the Parsen window approach. Or we can specify the number of samples within the volume Kn and grow the volume until it includes, for instance, Kn equals square root of n samples. This is the k-nearest neighbor approach. In the following sections, we discuss them in detail.